Hi, this is another tutorial to classify weather images, but this tutorial is based on VGG19 network. So basically we are going to install Python libraries, and after the installation we are going to take the out-of-the-box VGG model and change the last layer and transform it to our requirements. So as we did in our previous tutorial, I really recommend you to do it as well. First of all, we are going to build a conda environment. If you have it already from our previous tutorial, you can use it. If not, if it's your first tutorial, you are most welcome to create the conda environment and install the relevant Python libraries. Please watch the first step of this tutorial. There is also a file in my GitHub that has all the pip install commands, so you can use copy and paste and install it instead of following this video. However, after finish the installation, we will start building the model or manipulating the VGG19 model and do the transfer learning. After installing the relevant Python libraries, we are ready to copy to download the dataset. The dataset is from Kaggle, and I will leave a link in the same command file. You can download the images, open the zip file, extract it, and organize the data in these folders. You can see there is a cloudy folder, foggy folder, rainy folder, sunshine, sunrise. So basically these are the images. This would be our dataset. So please follow this second step, downloading the images and copying to a relevant folder in your local machine. Please notice that the dataset has already a test data, that it will not be part of our training or validation, so you can copy this test data directly to your test folder. And the next phase would be writing some Python code in order to copy the data from the original folder to our train and validate folders. I explained it very deeply in my previous tutorial. It's basically the same process, so if you have done it already you can skip it. If not, just follow this code. Basically what we are doing here is copying about 80%, 85% of the data to a trained data, and the other 15% would be the validated data. Moreover, we are building 5 folders, so we can copy the information to each folder. Each folder is basically our category. We will create a function that will run repeatedly for each of the category. So this function would retrieve the information from the folder and do the whole copy process for each category. And then we are going to run it 5 times, since we have 5 categories. So as I said, I explained it in my previous tutorial, but you can follow the code, and the code will be available at my GitHub as well. Okay, now we are ready to build the model. As I said, we are not building a CNN model from scratch. We are using the VGG19 model as our baseline. So first of all, we are going to import some Keras libraries, and of course the VGG model, and then we'll start to manipulate the last layer of the model. Okay, after importing all the relevant libraries, we are going to start coding the model. The image size would be 150 on 150. That means that every image will be transformed to these dimensions. First of all, we will define the folder of our train images, and as well for our validation images. The next step would be data augmentation. Since we have only several hundreds of images in each category, it's really better to do some data augmentation. That means that we are going to do some duplication of the data with a slight change, that the model will have more images to train. For example, to do some zoom in, or to do horizontal flip to the data. And so the dataset will be imported from our folder, and we are going to do some modifications and some changes to the data, so the model would have more images to train. We're also going to rescale it to normalize the data, because each pixel has a value between 0 to 255, and we would like to rescale it between 0 and 1. And then we are going to input the information from the directory. This is a common practice in CNN models, and we are going to as argument send the train data gen, the target size, and we are going to use batch size of 32. That means that each batch would have 32 images, and it will be a categorical class mode. I can see that I have a bug here. Yes, of course I have to send the relevant arguments. This is a freestyle coding, so I can have some bugs, but I will correct it during the coding or during the runtime. So as you can see, we found about 1,274 trending images and about 226 validation images. Okay, now it's time to do the configuration of the VGG19 model. So The input shape, of course, will be the same input shape we have done with loading the images. The weight will be ImageNet, and the include top false is very important. This argument means that we are taking out the last fully connected layer. It's very important not to forget this argument, since we're going to replace the last layer with our layers. The next phase is changing the attributes of the layers to a non-trainable. That means that all the existing layers in the VGG19 model that exists as out of the box will be non-trainable, because we would like to train only our new layers. Basically, the concept of this transfer learning means that the VGG model is a state-of-the-art model, so we are not going to train it once again. We only would like to train our specific layers, and we would like to use the existing trainable layers that exist inside the VGG19 model. So next we would like to see that we have 5 categories. You can see that these are the list of the folders inside our train folders. Okay, you can see these are the names like cloudy, foggy, and trainy as well. And basically what we need only the number of these classes. We have 5 classes, but if in the future we'd like to add 6, 7, and 8, this code can be run without do any real changes. So now we will see how many classes. The answer, of course, is 5. Okay, now we are building our model. We are starting with a fresh new model, and we are going to define it as sequential. Then we are going to add our VGG model. I remind you, it's a not trainable model. Now we are adding another layer, a flattened layer, and the last layer, it's our dense fully connected layer, which has class number which is 5, and activation function, it's a softmax. And let's print the summary of this model and see that it's working correctly. As you can see, this is the definition of the model. Everything seems fine. Next step is the compile step. That means defining the optimizer. We're going to use Adam, the loss function, which is of course categorical since we have several categories, and the matrix will be accuracy. We will import the model checkpoints and early stopping in order to do a save of the updated model each time the accuracy is better from the previous time, and to do early stopping if the training can be finished before the last epoch. So please follow this coding. As I said earlier, everything will be in my GitHub repository. One of the parameters is the name of the saved model. You can see my model will be named as my VGG19.h5. The next step is the Feit command. That means this is the training process of the model. The return value is I call it a result, and then we are going to analyze this result and to watch the accuracy and the loss. As for now, it's a straightforward process. We are sending the train data, the validation data, how many epochs. We are going to run it on 15 epochs. And as for callbacks, we are going to add the checkpoint and the early stopping variables we defined earlier. And now we are adding some code for plotting a diagram that will project the accuracy versus the validation accuracy, and of course the loss and the validation loss. Two diagrams. Okay, and the training has started. It's a really short process, only 15 epochs. Basically, it will be stopped before the last epoch, so you can follow this process. Okay, the training is near the end, near the finish process. You can see this is the accuracy and this is the loss. Seems like a good result. So and now we will write a code to test and predict an image and to see if our model is accurate enough. So as previous, we are starting with the import the relevant functions and libraries, and next we are going to define a function that help us to transform the image that will be ready to our model. We are building an array, a simple array with all our 5 categories. A very simple process. We are just copying it from our folders names. Now we are loading our pre-saved model. And now we are defining our new function. I call it prepare image. The argument would be the path in my local machine to the image. First we are loading the image, and next we are going to transform the image to a numpy array. I'm adding another dimension to the image, and now you can see that I have a bug. Instead of a equal character, I did a minus, and I fixed it later. And now I'm choosing one of the images. Let's choose this sunshine free image. Now I'm running our function and analyzing the results. After running the prediction, we will get an array of results, and we have to analyze, basically look for the position of the best prediction in our array. So let's run it. I have some syntax error. Okay, we have to fix the load image. As I said, it's a freestyle coding, so it's I can do some mistakes, but now it's fixed. And this is the result. And we would use a numpy function to retrieve the large, not the large, the maximum value from this array. So using the argmax function, we will get the answer of the highest position of the maximum value. So once again, let's run the prediction. You can see that the position is 3. So it looks like there is a problem, since position 3 is not sunrise. So because sunrise is position 4. So let's finish the coding, and then we will fix the problem. So now we will print the text behind this index, and the text is shine. So let's fix the bug. We have to replace this minus character with the equal character, and then I believe that the model prediction will be better. So let's run it again. Okay, this is the money time. So you can see that the prediction is sunrise, the same as this image. So let's take another image. Let's take this cloudy image. Copy the name of the image and run the model again. So now we are hoping to see cloudy. Yes, it's cloudy. That means that the model works fine. Let's choose another image. Let's choose this rainy image. Once again, copy the name of the file. And let's see the outcome. Yes, it's raining. That's good. Hope you enjoyed this tutorial. Thank you very much.